So here is another example with a DC circuit. We have a voltage source V1 with a value of 1 volt. We have resistor R1 with a value of 1K. We have resistor R2 and R3 each having value of 1K. And the net or the wires have been labeled as here level A, here the level B, and here level C. So what we see here, we are running the dot OP analysis right over here, which is the operating point analysis, which will provide us the currents and the voltage in this network. So once that is done, we see that all values are given, and we just come and click this symbol run, and we'll see what voltages and currents are there in this network. So before that, always it is advised to have a theoretical calculations. So for that, you see here this network has been redrawn with the exact same values of the components and the devices which is shown in the schematic. So right here we have this voltage source of 1 volt and the resistors R1, R2 and R3 of each having 1K value, and the total current that flows through the network is indicated by I. So it's easy to calculate this current, which is the by Ohm's law, the ratio of voltage divided by total resistance. So voltage is 1 volt, resistance is 1 plus 1 plus 1, that is 3 kilo ohm. So 1 over 3 kilo ohm, and the current would be 0.33 milliampere. So now the same current flows through all of these resistors. So therefore we'll say that IR1 equal to IR2 equal to IR3 equal to I, which is 0.33 milliampere. So if you want to calculate the voltage drop across each of these resistors, here it would be, let's say, the voltage drop across R1 is VR1, the voltage drop across R2 will be VR2, and the voltage drop across R3 will be VR3. So we can write here VR1 would be the current multiplied by the value of that resistors, which is R1 actually here, and VR2 will be the current multiplied by the value of that resistor. Remember, the current I is the current through each of these resistors, that is IR1, IR2 and IR3 are same as the total current into the network, which is I. And finally VR3 would be given as I times multiplied by R3. So we see here the value of I is 0.33 milliampere multiplied by the value of R1, which is 1 kilo ohm. So we can actually see that the the value of voltage drop across this one will be 0.33 volt or 330 millivolt, and the voltage drop across VR2 is basically uh, the voltage difference between these two nodes. Okay, and we can see that it is again 0.33 volt, same as above. So it is 0.33 milliampere multiplied by 1K, 0.33 volt, and voltage drop across resistor R3 is 0.33 milliampere multiplied by the value of resistor R3, which is 0.33 volt. So let's see if this calculation matches with our simulated results. So we come back to the screen and we are done with the implementation. We click the symbol run, and here are our results. So we see here VB is the node voltage, the voltage at node B. Right over here we see here in the schematic, which is 0.66 volt. So it is understood that we are the voltage at node B, remember, is not the voltage drop across resistor R2. The voltage drop across R2 will be the difference between the node voltages at B and C. Okay, so voltage at node C is 0.33 right over here, and VB minus VC would be 0.66 minus 0.33, which is what we calculated, 0.33 volts or 330 millivolts. Voltage at node A is calculated at 1 volt, which is obvious, which is the voltage source of 1 volt we have connected. Now you see IR3, IR1 and IR2, they are actually the the current, device currents, or the current through the resistors, which was calculated as 0.33 milliampere. You see here 0.33 milliamperes, and they are what we have calculated. Now the current delivered by the voltage source is again same as 0.33 milliampere. Remember, the negative sign indicates, is just a convention. The negative sign indicates the current coming out of the voltage source, which is being delivered to the components, and the positive sign of the current indicates the current that is being entered into the component, or the power consume. We'll explain that later, the concept of power consumption. All right, so this is all for this particular network.